This is Mr. Martin. These are the video notes for Geometry Honor, section 10.3. Lots of definitions and theorems in this section related to circles. So make sure that you're doing all the homework and asking questions if you have them. Make sure you're keeping on top of this chapter because you don't want to get behind. So some of these things we already know. So for example, arc, we know it consists of 2 points on a circle and all points on the circle needed to connect the 2 points by a single path. So I mean, it's just a fancy way to say that I've got 2 points. So here's 1 point, here's another point, and then if I connect these two, all those points on the circle that I've made red now would consist of the arc. So the 2 points and that red arc. So we're going to talk about three types of arcs. We're going to talk about a minor arc whose measure is less than 180. So notice arc AB here is less than 180. And recall that the symbol for arc, when we're doing it in symbol form, is that curvy shape on top. And then if I've got a minor or a major arc is an arc whose measure is greater than 180 degrees. And make sure that you use 3 letters to name. Okay? So otherwise you're not going to know um, what part of the circle you want. So for example, over here, this dotted arc here is a minor arc CD, but if I want to talk about the major arc, the solid part, I'm going to have to add another point here. I'm going to call it P. So then I would talk about the major arc CPD. Okay, so this is one of those rare cases where we actually have to use 3 letters. And then if we look at this other part here, if we want to name the major arc and the minor arc here would be arc AB, and then that would be the red one, and then the black arc here would be major arc AXB. So 3 letters for a major arc and also for the next one, which we'll talk about, semicircle, and 2 letters with the arc symbol to name a minor arc. So if we've got a semicircle, again, you've got to name or use 3 letters. So here's my circle, there's a diameter, we'll call that A, we'll call that B. I'm going to put a point here, C, and a point here, D. So with the semicircle, again, you have to use 3 letters because you need to know which half of the circle you're talking about. So in this case, the top half would be arc ACB, and then the bottom half would be arc ADB. Alright, so you need to specify. Now, we're going to talk a lot about congruent arcs, congruent chords, congruent central angles. When we're talking about congruent arcs, if arcs have the same measure and are parts of the same circle or congruent circles, so they need to have both of these characteristics. They have to be the same measure and they have to be part of the same circle or congruent circles. Then they are congruent. So that's really important that you make sure they have both of those characteristics. So with a circle, we can have a central angle. So I'm going to call this AOC. So I can have a central angle, that would be angle AOC. We can have a chord associated with that central angle, so I'm going to draw the chord in there. We can have a chord that would be segment AC, and we can have an arc that would be arc AC. So we've got this angle, we've got this chord, we've got this arc. They are all related to each other. Okay, we would say that we have the chord associated with the arc and the central angle, or the chord and the central angle associated with the arc. So we always have these 3 things that are related to each other. So these 6 theorems basically are relating congruent chords, congruent arcs, and congruent central angles. Okay, and when you write these in your proofs, use these abbreviations. Feel free to use the congruent symbol instead of writing out congruent. So if we have central angles that are congruent, then the intercepted arcs are congruent. So let's take a look down here. So this would be this first picture here. If I know that these central angles are congruent, then I know that these arcs are congruent. So PQ is congruent to RS. And it works the other way around. So if the arcs are congruent, then the central angles are congruent. All right, and that's the second one here. If the arcs are congruent, then the corresponding central angles are congruent. So the next one, if the chords are congruent, then the corresponding central angles are congruent. And the next one is the converse of that. If the central angles are congruent, then the corresponding chords are congruent. So let's take a look at that picture down here. So here you notice I have central angles and chords now. So if either of these are congruent, the others are congruent. And then the last two up here, if the arcs are congruent, the corresponding chords are congruent. And if the chords are congruent, the corresponding arcs are congruent. So that's our last picture. We're looking at the chords and the arcs. So basically, in the same circle or congruent circles, if any pair of parts are congruent, all the others are congruent. So congruent chords, congruent arcs, congruent central angles. And notice these arrows going forwards and backwards means that these can go any way. So this is basically a summary of the 6 theorems that we just talked about, and you want to make sure that you're using it in the appropriate direction. So what you know first implies what you are proving. So again, a lot of information. I know I went through it quickly, but make sure you're doing the practice problems so that you can help yourself to internalize these. So here's our example, and I'm going to actually pause the video and work out the solution just to make the video a little bit shorter so you can try it too. And when you come back, you can compare your solution with my solution. And if you have any things that are different, again, make sure that you ask me in class. So I'm going to pause the video in 3, 2, 1. All right, so here's the proof completed. And if we want to prove these arcs congruent, so AB and DC over here in the picture, so we already have these central angles congruent. The only problem is that we need to know that the circles are congruent. And then if the central angles are congruent and the triangles are congruent, then we know the corresponding arcs are going to be congruent. So most of this proof is trying to get that circle P is congruent to circle Q, and in order to get the circles congruent, you need to show that they have congruent radii. So my first step is going to get to get RP congruent to RQ. And if we look at this whole big triangle RPQ, we see that it's got 2 angles congruent. So that means that the sides opposite them are congruent. That's how we get RP congruent to RQ. And if I use steps 3 and 4, I'm going to subtract the segments that were given in step 3 from the segments that we just proved congruent in step 4 to get AP congruent to DQ. And AP and DQ, these are the radii of the 2 circles. So if congruent segments, the ones in step 3, are subtracted from congruent segments, the ones in step 4, the differences are congruent. Now that I have these radii congruent, I can say that circle P is congruent to circle Q, because if radii of circles are congruent, then the circles are congruent. And once I have the circles congruent, I know that arc AB has to be congruent to arc CD because I have congruent central angles. That's step 2. That implies congruent corresponding arcs. All right, so if you have any questions, make sure that you write those down and ask me during class. Otherwise, we'll see you next time.